Part 2 then says calculate the area of triangle OAB for the smaller value of alpha from part 1. So we're going to use the 12.7 from part 1. So make sure you've got that number on your calculator, the full value, the 12.688466676. And we need to make sure we're using that full number. So you're going to save that into your memory. So that's the first thing that I've done. I've got this 12.688 and I've saved it into my memory A. If you don't know how to save values into the memory of your calculator, I've done a video on it, and it's really important that you do that so that you get the perfectly accurate answer for this question. If you don't, if you just use 12.7, you're going to get the question wrong, even though you're going to use the correct method. So that's really important. That's the first thing you need to do. Anyway, once you've done that, this is the situation. We have got a right angled triangle, and we know it's a right angled triangle because we were told that O to A and O to B are perpendicular. So our job is to find the length of O to B and O to A and do half the base times the height. So we need to find these lengths. We need the modulus, the magnitude of O to B and O to A. So I call that 3D Pythagoras. We're going to square these numbers, add them together and square root them. So we're going to have 2 cos 12.7 all squared plus 4 sine 12.7 all squared plus 3 squared, added together, square rooted. Okay, and when you do that on your calculator using the saved number for 12.7, and that comes out at 3.68. But obviously it's not actually 3.68, that is 3.68 rounded to 3 significant figures, and I'm going to save the real 3.68 into my memory B. So this is saved into memory A, and I've got 3.68 saved into memory B. I'm going to do the same thing with O to A, and that's going to be 3 sine 12.7 all squared plus 2 cos 12.7 all squared plus negative 1 squared, which is 1. And we're going to square root that. And when we do that one, that one comes out at 2.29. Again, to 3 significant figures, that is. And I'm going to save the real 2.29 into memory C. So the last job now is to do the easy bit, the half of the base. So we've got the length of O to A is 2.29 to 3 significant and 3.68 down here. Again, that's rounded though. And then the area is going to be half of the real 2.29 times the real 3.68, and that finally comes out to 3 significant figures at 4.22.